Okay, well, I've got that it's noon, right on the nose, so why don't we go ahead and get started? I'm Matt Russell. I'm an extension specialist with the University of Minnesota Department of Forest Resources, and this is the Sustainable Forest Education Cooperative and University of Minnesota Extension Forestry webinar series. And so before we hand things over to Mike to talk about today's topic, I just wanted to introduce you to a couple of things. One of those being the WebEx system, which we're using today for this webinar. You should be seeing Mike's slides, Making Better Decisions, the argument for structured decision making in front of you, and also a camera of Mike as well. And so that's there. The other things I especially want to point you to is the chat area. And so in chat, we encourage you to ask questions, to provide feedback and comments to the speaker. And so the best way to do that is in the lower right area. You should see an area called chat and encourage you to enter messages there. And you can send them to the host, and the host is me. And so I'll get those questions and then I'll relay those to Mike as he's going through his presentation. And Mike has mentioned he's got a couple of convenient stopping points throughout his presentation. So I encourage you to, as you have questions, to type them in into that chat area. And I'll be also sharing a couple of links in that chat area as well, in addition to the CEU credit form and a webinar feedback form toward the end of the webinar. And so that's the WebEx system in a nutshell. And we're really happy to have this topic as a part of this webinar series. In a nutshell, this is really about how to make difficult choices. And Mike is going to step through a lot of what he does in his work and helping people to go through that process of structured decision making. And so with that, I want to introduce Mike Larson. So Mike is really the lead of a research group in the DNR in Grand Rapids that really studies the ecology and population status of forest wildlife, including things like deer, bear, moose, wolves, and grouse. And so he's also an adjunct assistant professor in the Department of Fisheries, Wildlife, and Conservation Biology at the University of Minnesota. And he's really a consultant in this area of decision analysis for the DNR and a lot of other agency partners that the DNR works with. He's been working on adaptive management and structured decision making for a long time, including as a postdoc with the USGS at a wildlife research center in Maryland. And he's got a bachelor's in biology, a master's in wildlife from Michigan State, and a PhD in wildlife from the University of Missouri. And so with that, Mike, I'll hand things over to you, and I'll mute myself and turn my video off, and so you can take it from here.
Thanks a lot, Matt, and thanks everyone for attending this lunch webinar. I assume Matt or somebody will let me know if you can't hear me. I've got a window or a screen off here on the side that hopefully I can see some chat stuff. But thanks again for the introduction, Matt. Start by trying to change my slides. What I intend to talk about today is what SDM is and why it's a good thing to consider using when you're facing difficult problems and decisions. And I'm going to focus on a few basic components of structured decision making and hopefully leave you with a few basic things that are relatively easy to remember as take-home points, including ProACT, which is a handy initialism in terms of the algorithm we step through, the major components of a decision, something we refer to as an objectives hierarchy, and a consequences table. At the end, I will hopefully have time to step through a full example of applying SDM in wildlife management. And as Matt mentioned, I do intend to pause partway through after some of these sections for question and discussions, but hopefully we'll leave some time at the end for questions and discussion as well. I've kept track of this note since I first read it in conservation biology quite a long time ago, but we are not so much rational creatures as we are creatures of rationalizing, or capable of rationalizing. We face a lot of decisions in our work today that are really nothing like the kinds of decisions that our brains evolved making. And so the higher order thinking that we do has to do with our socialization as social creatures and explaining why we do things to other people. And so we tend to make choices and make up stories for why they're good choices, as opposed to actually stepping through. So our natural tendencies when it comes to decision making fall back on a lot of rules of thumb and relatively sloppy thinking. And the intention of my talk today and decision analysis in general and structured decision making is to snap us out of that a bit and help us remember some really common um, uh, common sense steps for making sure we're not skipping over things. So there's a guy named Ralph Keeney who's a leader in this field of decision analysis, and he has a paper with a couple diagrams I'm going to use today. They're both structured like this. And this is a diagram of his assessment of how most decisions are actually made. And so if you start on the left-hand side of the figure, the vertical axis represents all the decisions we face in a particular unit of time, let's say a day or a week or a month. And at the bottom, most decisions that we face throughout our life have relatively small consequences. And so we don't need to spend a whole lot of time thinking about them or analyzing them. Just going off the cuff and going with our gut instinct is probably going to be fine because the consequences are minor enough that even if it's the least optimal choice or the less than optimal choice, nothing bad's going to happen. And at the top are what are referred to as no-brainers. So the best decision to make tends to be very obvious. And so there's a whole chunk of decisions that fall into that category. So it's a relatively small proportion of all decisions that we face that are actually worthy of some thought and deeper analysis. Of those, we tend to, as humans tend to procrastinate and spend too little time thinking about decisions, regardless how big, consequential, or complex they are. And so those smaller arrows off to the right represent the very few decisions that get much thought. And in Keeney's estimation, only about half of the decisions that are worthy of some thought get any structured or clear thinking applied to them. And of those, again, it's an overall very small percentage to get systematic thought in something like a decision analysis framework. So starting at the beginning, what is a decision, and what do we do as managers and practitioners and decision makers in natural resource management? Whether we think of it as a problem, an issue, when something hits our desk or our inbox, it's probably going to lead to the need to make a decision. And so Robin Gregory, another primary author in this field of literature, argues in a textbook that because you're going to end up needing to make a decision, it's probably best to start framing it as a decision from the very beginning. So can the problem, issue, or challenge or controversy that you're facing be framed in terms of a decision? And a decision is simply making a choice of one course of action from among a set of possible courses of action. So if you're making a choice, you're making a decision. If you're committing resources in either your time, your staff's time, or money, that requires a decision to make that commitment of resources. Structured decision-making is a robust field of work, both academically and in applied settings. So there's it's based on a lot of established theory, tools, techniques, and concepts related to making complex decisions that we're not very good as humans in making if left to our own devices. And the basic idea of SDM is to take a decision problem and breaking it into its, deconstruct it into its primary components, analyzing those components separately at first, so that we can get over some of the hurdles that are making it a challenging decision for us, and then synthesize those pieces back together, and make a decision in the full context of the decision as we're facing it. So what's different about SDM versus a familiar approach or traditional approach, or how we just might go about making decisions if we don't know about structured decision making or decision analysis? And one thing we hear a lot about is the emphasis on objectivity, especially in natural resource management. So hopefully, or I'm guessing that most of you have heard the phrase science-based decisions, or our organization, or I as a person try to make science-based decisions. And science certainly has an important role to play, but it ignores that phrase, and that approach to decision making ignores the fact that every decision has a component that's related to our values. And so there's a lot of subjectivity in our decision making. And so it's better to acknowledge that so that we can address it fully, as opposed to pretending it doesn't exist. And again, back to the left-hand column, another common tactic that we resort to when we face complex problems or complex decisions is to simplify them. Our brain can only hold 2 or 3 things in active memory and work on them at the same time. And so in these big complex decisions that we face, we can't deal with it all at once in our heads. And so we often simplify and in simplifying, we make a bunch of assumptions about the decision. And in the end, we can simplify the decision so much that it no longer represents the actual decision in the real world that we're facing. And the SDM approach handles that same problem of too much complexity to handle at once by, instead of simplifying, simply structuring the decision. So breaking it into those component parts, into smaller pieces that we can handle individually, but not losing any of the pieces, and being able to build it back up into that full picture of the real situation. There's a handy little book called Smart Choices. And it only costs about $10 if you want to go out on Amazon or someplace else to find it. And I highly recommend that as a great entry point into SDM and decision analysis if you are brand new. But the idea is that there are 5 components to every decision. Any decision that any of us is facing has at least these 5 components. The problem, which is the framing and scoping of the decision, objectives, alternatives, consequences, and trade-offs. And I'll be talking a lot more about each of these steps along the way, but just the idea that these are what I refer to as the first level of structuring, is identifying these 5 parts of the decision that we're facing. So back to that figure by Keeney, ideally, all those, that subset of decisions that we face that are worthy of some thought should get, all of them should get some systematic thought. And this first level of structuring and identifying those 5 components of a decision and understanding what they are and their different roles in making the decision is what we refer to as clear thinking, consistent with decision analysis. And actually that alone can get you through any impediments to making about 75% of those decisions. So it doesn't, even though there's a rich toolbox of concepts and tools to use within the SDM approach, it's a very tiny fraction of decisions that require a ton of analysis or analysis to the extent that you might want a decision consultant or decision coach. And so you learn a little bit more about SDM and you get those little arrows off to the right. So basically when we face a decision, they're often complex or difficult for 1 or 2 common reasons, and we can get over and get to a place of being comfortable making the decision if we just address those one or two impediments. And so just usually those impediments are related to one of those 5 components. So we're arguing for using SDM to, at the very least, apply clear thinking to the complex decisions that we face. So back to the list of those 5 components. First off, we have the problem. The PR is for problem, and it's the decision problem. And when we realize that there's a decision to make, it's usually based on some trigger. Again, someone comes to us with a problem, or we stumble across one, but it's something compels us to want to make a decision. And it's a good practice to ask yourself if that's actually the right decision. So when we think about framing the problem, we think about the spatial and temporal context and scope of them. We can think about who the decision maker should be, who it is, or who it should be, or who it could be, who has the authority to commit resources to implementing a decision. And it's a good practice, again, to think about the decision as you first come to it, or as it first comes to you, but then ask yourself if there's a different way to frame the question from a slightly different perspective at a slightly different scale, or thinking about who else might have a role to play in making a good decision, to see if there's a better framing or a more productive framing of the decision. And so before we get into any of the details about what the decision, the rest of the decision components are, you want to make sure that you're addressing the right question, the right problem, or at least the best framing given the circumstances. The second major component of decision making, or a decision, is the objectives. And this refers to, this is the component and the step where we think about and discuss what we care about. And I say here, what you care about. So if there's a single decision maker thinking about just you making a decision, you're making the decision because of a values judgment or to achieve certain objectives and values. And so again, given a lot of us have training in science and biology, we focus a lot on the objectivity and the science, and oftentimes to the exclusion of acknowledging that there's a values component. And so the values, this objective step, is often overlooked, or at least doesn't get enough attention in terms of really digging in and finding out what all of the values are and the full breadth of objectives are for a particular decision and the stakeholders involved with a particular decision. The third main component is the alternatives, or those alternative courses of action, also referred to as options. And by thinking about alternatives as a standalone thing, we can be more creative in trying to think outside the box and come up with unique or different solutions and ways to solve a problem, and think about different courses of action that we could take. Because again, our natural tendency is to do what we've always done, or do what's simplest, or we tend to anchor on early ideas. Often as soon as a decision comes up, we focus a lot on alternatives and say, well, that's the problem, this is what we should do. And once someone specifies a course of action, it can be very difficult to branch out from that initial idea and open our minds to really unique or different alternatives that could actually be better for a given situation. The fourth component is consequences. So given the problem framing and the objectives we're trying to achieve and the different ways we could achieve those objectives with the different alternatives, there's an inherent need to predict consequences. And again, it's something that we often overlook, at least in detail, but every time we make a decision, it's based on some prediction of what's going to happen in the future. And to make that prediction, we rely on how we think the world works, or how we think the system that we're operating in works. And that's science. What is our understanding of how the system works? And that understanding is always represented in some sort of model. So models, again, are inherent in decision making. Most of the time, those models are quite simple and reside only in our brains. But when we're working with coworkers or with stakeholders or with someone at a higher level in our organizations, we need to justify our decisions and explain our decisions and incorporate different perspectives. So we need to reach a common understanding of how the system works. And the only way to do that is to articulate the models that we're using, or the models that we're relying on to make the predictions. And so this is the component where we can address the presence, type, and type of uncertainty, and whether or not we can resolve some of that uncertainty, or if we need to act and decide in the face of that uncertainty. So you'll notice that the objectives and consequences components and steps in this process of analyzing a decision are separate, so that we isolate conversations and thought around values and subjectivity from the science and the objectivity. Because again, a lot of times without some sort of structuring or framing, we end up arguing about the science or the predictions related to a particular decision, when really it boils down to a values difference. So identifying where any differences of opinion lie, or any conflict lies, it's often either a science issue or a values issue, but we get those confounded, and it works much, much better and is much clearer when you separate those two. And the last component, the phrase for it is trade-offs, and that's because most of the decisions we face are difficult because we're trying to weigh different objectives. We have competing objectives that if a particular course of action does better for one objective, by definition, it's going to perform. That alternative is going to perform less well on another objective. So how do we make those trade-offs between the apples and oranges, the different things we care about, or the different things that different stakeholders care about? But the idea is much broader than just trade-offs, because when there's a lot of uncertainty in a decision and making predictions, there's this idea of risk and our risk attitude and how we're going to deal with approaching that risk. And so even with all the consequences predicted, we can use different criteria to select the best alternative from the set of alternatives. So I'm going to introduce you to the idea of a consequence table, what we refer to as a consequence table in SDM. And this is a tool that I think is one of the easiest to pick up and the best things to remember and think about and even fill out, because it captures all the information that's relevant to a particular decision in a very concise way. So at the top, and what's defining your table, is the problem statement. So you can boil down even the most complex decisions into a single statement. Now the statement might be a little long, but basically a particular decision maker wants to do some sort of action to achieve some sort of result in some context. And so a brief statement of what the problem is can live at the top. And that's the first component, the first of the 5 components of a decision. The second one is the objectives. So what are those objectives? The objectives can, and this table can go either way. The objectives can be in columns or rows, vice versa. But we list out what those important objectives are very, very clearly in separate columns or rows. And on the other axis are the alternatives. What are the different courses of action we could take? And then the body of the table is where the consequences live. So when we predict consequences, we have to predict the outcome of each alternative relative to each objective. And so these can be quantified if we use some sort of numerical model or numerical estimation, but they can be qualitative descriptions of, good, better, best, or something like that. But so if someone presented me with a completed consequence table for a particular decision, that would give me a full understanding of the decision context. And then the last component, that last step, the trade-offs, is how we go about reviewing and making a decision given the consequences. Because given the consequences, that isn't going to necessarily make the best option jump out at you. We have more choices to make in terms of if we want to take a particular course of action that might be hedging our bets relative to some risk and uncertainty versus choosing an alternative that would guarantee some minimal amount of results relative to important objectives. So it brings us to that fifth component, but the fifth component is actually making the choice and implementing the decision. So that's an introduction or overview to the five main components of every decision, and those first few slides about kind of why it's good to give systematic thought that's consistent with decision analysis to those complex decisions that are worthy of some thought.
Great. Well, thanks for that, Mike. This is Matt again. Just a reminder to folks, if you do have questions, comments, you can put them in that chat area. That should be in the lower right corner of the WebEx system. We do have one question, Mike, and it's going back to the consequences table. And you talked about how they can be either quantitative or qualitative values. So what are the benefits of using either approach in some of the things that you've worked with, whether that be natural resource problems, quantitative versus qualitative consequences, and trying to assess those?
Thanks for the question. That reminds me to provide some context here. As when we think about using SDM and giving some systematic thought, or especially if you want to engage with a decision analyst for some advice or to get started on a decision problem, sometimes I forget to say that we only need to use decision analysis and use the SDM approach. It's all intended to help a decision maker better understand the decision and reach a point at which the decision maker is comfortable making the decision, thinking or knowing that they're making the best choice. So there are these five components. There's all kinds of tools and approaches, and you can analyze a decision front to back and spend lots of time, but it's completely unnecessary to do a full-blown decision analysis if the decision doesn't warrant it. So that's related to this question because when we're facing a decision, part of that framing is deciding how quickly do we need to make this decision? How much time and energy do we want to devote to making this decision? If it's the closer we are to the quick and dirty end of the spectrum or urgency end of the spectrum, certainly we try to run through the basic components of a decision relatively quickly to see where the main impediment might lie. And in those first couple iterations of analyzing the decision, we usually start with qualitative consequences. We might spend a little bit of time talking about what, in the consequences step, what the model is, what the main drivers in the system are, how different components of a system work together. But in making these predictions or the first idea of a prediction, you can write it down in words that qualitatively. And beyond that, it's a matter of the costs and benefits. So to build a big numerical or computer model, might be really beneficial in some circumstances, and in others not. But it gets to this idea of when you specify your objectives, we need to identify a metric. How are we going to measure performance on that objective? And so there is this idea of different ways we can measure. And so we can use a real world, a natural scale that would be most likely numerical. But a lot of times we end up using an index. So say on a scale of 1 to 5, how well does a particular alternative perform? And so those relative index scales can be very qualitative as well, even though we're representing them with numbers. So hopefully that helps a little bit.
Great, thanks, Mike. Yeah, not seeing any other questions right now. So again, feel free as you have comments to enter them into that chat area.
Great. So I've got a few slides here, kind of trying to place SDM in some broader context. And I mentioned before that often we realize that we have a decision to make due to some trigger. Something happens, and we refer to that as the trigger. What's the reason that we're even thinking about spending time analyzing this decision? And then on the far right, once you realize it's a decision or feel like there's a decision to make, the end point is actually implementing the decision. So what happens between those 2 points is the framework we use to engage with the decision problem. And SDM is this overarching framework. I often refer to it, and it's often referred to as an approach. So SDM itself is not a method or a tool. It's the entire framework that that we use when we approach a decision. But as part of the process of analyzing the decision, there are lots of different methods we can use. And by methods, I'm thinking of things that we do that tend to bring information into the decision context. So something like scenario planning, people use in a decision context and to help them understand decisions and alternative futures. But it's not a complete replacement. It's not like choosing scenario planning or SDM. Scenario planning can be a useful method for thinking about consequences and alternative futures, but it would be used and is often best used in that broader framework of making decisions with a structured approach like SDM. Likewise, tools like zonation that some of you may be familiar with in terms of land planning sorts of things, but any kind of model or analysis is used to analyze data. But within that SDM framework, we now have a purpose for using those tools. And we're asking for very specific products from those tools. We're not just using the tools for everything that they can do. We decide the framework and what consequences we're trying to predict and use those tools most efficiently. And we like to use SDM and at least use clear thinking consistent with decision analysis for all those decisions that are worthy of some thought. But there definitely are circumstances in which SDM is not going to be useful or helpful. So if we look at the left-hand axis first, we can think of the objectives. And certainly if the objectives are clear, and if they're one or just a few objectives, that's relatively easy to handle. In fact, SDM, you can have as many objectives as there are that are relevant to the decision, and they can even be competing objectives. Like I said before, SDM can deal with competing objectives and this idea of trade-offs, but at the top of that scale, you'll see disputed objectives. So if you have stakeholders that don't acknowledge the validity of other people's values, you're going to have conflict. And SDM isn't the framework to use to resolve that conflict. There's a separate set of tools and concepts in conflict management. But again, from an SDM framework or approach perspective, that gives us a reason to seek conflict management, And the purpose is to resolve not necessarily all the conflict between stakeholders, but that conflict that's related to acknowledging the validity of other people's values. And that's all the farther you need to get, then you're back within the realm of being able to use SDM. And on the x-axis along the bottom, we can refer to the science or the uncertainty. So it's simplest on the left in terms of how the system works and predicting the consequences. If things are very well understood and there's very little uncertainty, that's easier. And SDM can be used to help make decisions in the face of uncertainty. So the presence of uncertainty is actually always present in some form and to some degree. That doesn't preclude SDM. In fact, they're good. SDM is helpful for thinking about and addressing this idea of making decisions in the face of uncertainty. But you can move far enough right on that x-axis to the point of people disputing the science or how a system works. And again, there's a separate set of tools and approaches for dealing with that situation where stakeholders involved in making a decision simply don't agree on what's true or how a system works. And quickly, the good first cut at dealing with that is simply having the different parties articulate what their model of the system is and using those different models to predict consequences, because sometimes that dispute about the science or even the uncertainty about the science actually isn't relevant to the decision at all. If both competing models or understandings of how the system work both provide predicted consequences that point to the same alternative option, then clearly that difference of opinion about the science is not relevant to the decision. And then the last thing I'll mention about this diagram is you'll see adaptive management up there. That's a term that I think more people are familiar with and have heard about more than structured decision making. But adaptive management is simply a special case of SDM. So with adaptive management, we start with a decision at a particular place and time, and ideally we would use SDM to set up the analysis of that decision. But then this idea is that with adaptive management, we predict what the consequences of a particular action are going to be, and then we set up a monitoring system so we actually go and monitor the actual or realized consequences and compare them to our predictions. And by comparing the observed outcomes versus the predicted outcomes, we can learn we can learn about the system, and we can improve the models that we use to make those predictions. So adaptive management, repeating the same decision over time or in different places, and learning each time we apply that decision so that subsequent iterations, we can make better decisions. And what is this idea of a good decision? Decision makers and decisions are often judged by whether the outcome was perfect or best. But actually what makes a good decision is the process that we use to generate it. And SDM is one of those good processes. And we shouldn't rely on the actual outcome of a decision to judge as the only way to judge the quality of the decision at the front end, because we can't eliminate uncertainty. We're always making decisions in the face of uncertainty, and so our decisions can help shift the probabilities of certain outcomes, but we often can't preclude undesirable outcomes. And the other idea is that in dealing with natural resource systems, forest management, for example, there are lots of drivers and systems, and we don't have perfect control of all of those things. So all we can do is in implementing decisions and making decisions, we're trying to set the stage for the best possible outcomes, but we don't have perfect control. So you want to use a good process, and stakeholders can often be engaged in decisions, in conversations about this as well, and make it easier to accept certain undesirable outcomes if that wasn't the intent of the decision, or the idea that not everything is within the decision maker's control. So SDM yields decisions that are more likely to achieve objectives and are more likely to be accepted by others. So by being deliberative and thorough and explicitly incorporating values, and especially competing values or different values of different stakeholders, but also relies on science um, and best scientific information, as well as being robust to uncertainty, sets you up to actually achieve the objectives that you're trying to achieve. It's the best way to do that. Um, and using an SDM approach also results in decisions that are more likely to be accepted by others, both stakeholders and people that we need to justify our decisions to, or if we're making a decision as a recommendation to a decision maker, um, uh, other people accept those decisions and those analyses because of it incorporates competing values and what different people care about. It clarifies and separates the roles of science and values, but it's also it can be very transparent and explicit. So it lays bare something like that consequence table, uh, lays bare the logic and the rationale and the analysis and the resulting analysis that went into making that decision or recommendation. And here's a slide that gets back to a little bit my response to that first question is SDM is very scalable. Again, it's an approach. It's not a prescriptive thing that you have to uh, spend a certain amount of time on or do all of the things all of the time. So it can be you or any individual. It can help individuals make decisions. It can help groups make decisions. But if it's just an individual person and is thinking about a decision that's worthy of some thought, and you have anywhere from a few minutes on, and you want to make that decision quickly, you can use SDM. So apply that clear thinking, jot down your ideas about those 5 components, and ask yourself what's making this a difficult choice. Why is this not a no-brainer for me? And spending a little time thinking about that component of the problem that's the biggest impediment. You can do that very quickly. And so that's one end of the spectrum. At the other end of the spectrum, we can be thinking of big projects, high consequences with lots of stakeholders, and the need to work with committees, work with leaderships, work directly with stakeholders throughout a process that might take weeks or even years to work through, so that not only the ultimate decision maker, but the stakeholders and everyone else involved can be comfortable with what decision is made. So it's been used in all these different contexts and can be applied regardless of the number of people involved or the amount of time that's allotted for analyzing the decision. So let's see, it's about 1:45. I do have one full example I can step through relatively quickly in 5 to 10 minutes, but there definitely is time for questions. Any new questions come up?
Yeah, we've got one question from Cedar Creek. So thinking about global warming, climate change, I want to try to modify my forest in a sandy east central Minnesota area. It's a brushy red oak forest with the current problems of oak wilt, buckthorn, blister rust, and deer. Is this problem too complex to use SDM in making changes?
The short answer is no, it's not too complex. Uh, it's a complex system and there's a lot going on. My guess is that to the extent there are different, well, let me put it this way, managing that system or trying to intervene in that system to improve matters is going to involve lots of decisions. So I think SDM would be a great approach to start with in terms of framing, because the way that decision or that problem was articulated was conveyed the complexity, but had lots of components, and so you can ask yourself, is it it best? Do we want to spend our time addressing decisions related to one component of that or one driving force? Or if we do want to, what would it look like, and what are the main um, components when we think about this, again, decision framing? Who's the decision maker? Who are stakeholders, or who has a stake in the outcomes? And those pieces, what's the time and spatial scale? Those scaling and framing questions that we are all part of the problem component of SDM are relevant, and I think would be very helpful to start teasing apart where you want to go with that big of a problem.
Thanks, Mike. Not seeing any more questions, so yeah, I
Okay,
wonder if you might want to work through your example.
sure, yep. Um, So I'm going to talk about a decision that the regional wildlife manager here in Grand Rapids was facing a couple years ago, and we used a committee over a couple months to address harvest regulations for sharp-tailed grouse in the central Minnesota. I've worked on a variety of decision problems in lots of contexts with fisheries, parks, water management, a fair number of wildlife management things, but no explicit forest management decision yet. So unfortunately, I don't have a forestry specific decision problem, but hopefully this is a familiar enough idea of harvesting wildlife that this walking through the pieces for this applied decision will be helpful in figuring out and remembering what these decision problems are. So I have one slide for each of the 5 components, or at least the first 4. So the trigger was there's concern about the east central population of sharp-tailed grouse in Minnesota. The population experienced some rather noticeable declines in about the 2010 to 2013 time frame. And so we decided on the scope of addressing the east central population, not the all sharp-tailed statewide. And it's particularly the southern half of the east central range that was of primary concern, and where the survey results were indicating the steepest declines. The other framing issue in terms of the scope is that we decided to focus on harvest regulations for this particular decision, harvest regulations only, not habitat management, acknowledging that habitat and habitat management is a huge part of sharp-tail management. But again, this is, if you look at, again, brushlands in that part of the world, early successional forests and open lands and things, that whole system is very complex. So we chose to hone in on rather specific area of this problem to focus on for this decision, acknowledging that other decisions related to habitat management were being made as well. So I mentioned in the overview, and I'll touch again on the review, the other, I refer to it as a tool or concept in SDM that I'd like you to remember, is this idea of an objectives hierarchy. So each box here represents something that someone cares about relative to the decision as we framed it. So sharp-tailed grouse, East Central Minnesota, harvest regulations. And at the bottom of, so once we get those ideas and solicit those ideas, we can put them on this vertical scale of means and ends. So at the high end, we have these very strategic high-level objectives, kind of mission statement sorts of things that no one decision is going to directly influence, and those tend to live at the top of the hierarchy. And then we can ask ourselves, how would we achieve those objectives, those strategic objectives? And we start stepping down or organizing the objectives in this hierarchical manner, such that at the bottom of the hierarchy, we have means objectives. So the reason people care about them is because they deal with how we achieve higher level objectives. And so in this is what I refer to as a second level of structuring in SDM. So the objectives component, what is the landscape? What's our values model related to this particular decision? And by organizing it vertically like this, we can choose the level within the hierarchy that is most relevant to a particular decision. So we want to be able to focus on a relatively small subset of objectives to think about those primary trade-offs. And also, to the extent that there are stakeholders often come into a decision with preferred alternatives. We're very alternatives focused as people. And so we want to get people thinking at a higher level in the objectives hierarchy, because sometimes you can achieve the same objective with different methods, or by intervening in the system in different ways. And so you can get past some of the conflict or disagreement among stakeholders by acknowledging that at a higher level in this hierarchy, we actually do have shared values and things we both want to achieve. And so you can achieve those, what we refer to in SDM as fundamental objectives, and try to achieve them in different ways. So I'm not going to go through the details of all of these, but that's the overall concept, is that there's this idea of an objectives hierarchy. We separate means from ends and focus on a subset of the objectives that are most relevant to a particular decision context. And then for alternatives, we're varying various components of the harvest season. So length of the season, bag limits, who gets to hunt, and where they get to hunt. And you'll see them in the subsequent slides. And for consequences, I referenced models, the fact that we use model. Whenever the consequences step, we need to make predictions. All predictions are based on models of how we think the system works. And so we often start with a group with influence diagramming, just this flowchart type of idea, where you use a green rectangular box to represent alternatives or different actions we can take to intervene in the system. And then the hexagons in blue or purple there represent our objectives. And then all the other black circles and ovals represent different components of a system and how they interact. And doing something like influence diagramming or mind mapping, something like that, could be helpful for something like the example decision landscape that was described at that last question point. Is we use something like this to as a first articulation of the model we're using to make predictions. But this particular tool, this influence diagram, can also be helpful when we're trying to frame the decision and think about what scope and scale we want to try to influence, that we can influence and that we want to try to influence. So just this is a quick example of an influence diagram for this particular system. And here's the consequence table. So we have several alternatives down here on the side for different approaches to the harvest system, and then our 4 primary objectives across the top, and all the numerical results, and in parentheses are the ranges, acknowledging that there's a fair bit of uncertainty in each of these. But you'll notice kind of a takeaway here is that I highlighted green, the alternative that performed best on a particular objective, and then yellow represents the alternative that performed worst for a particular objective. And so looking at this consequence table, there isn't an alternative that is green straight across. If there were an alternative that were green straight across, that's the decision that you should make. But lo and behold, this is a difficult decision because we have competing objectives, and there's no one alternative that performs best on all objectives. And so the next step, if we can't, if we're not comfortable making the decision yet, we can try to simplify, or not simplify. The next level of analysis is to put all of these numerical consequences on the same scale. So same table, same columns and rows, but all the worst values get a 0 and the best values get a 1, and then all the other consequences, predicted consequences, are on that 0, 1 scale in the same relative position from the natural scale to the 0, 1 scale. And by doing that, then we can, they're all on the same 0 to 1 scale, so we can take an average for the rows to see overall the one number summary of how well a particular objective performs, alternative performs relative to our objectives. And in doing so, we can also incorporate this idea of this, this row of weights here in gray. So we have the 4 primary objectives, but they're not all equal. We don't value them the same. So some objectives are more important to us, are more important to the group than others. And so this gives us a way to explicitly and quantitatively incorporate that. So this is the sum on the right is the weighted average of these index values. And then you can look at the alternatives that have the highest values and ask ourselves, are those the does this look right? Does this feel right? Does that make sense to us? And so in the trade-offs, that final step is, okay, given that consequence table and those summarized results, what are we actually going to do? What choice is actually going to be made? Well, the top and bottom alternatives were ruled out because they didn't didn't perform well, and the primary stakeholder group came in wanting to move to a lottery system, but it was determined that none of those 3 were the best. So the row with the highest weighted sum, exclusive of those, was a partial closure, so closing the season in the southern half of the range, for example. But it turns out that the group really didn't want to do that, and the reason for it represented an objective that wasn't specified. And so we could have gone back and incorporated that objective to show our work and show why that wasn't best, but the group agreed that that would have, incorporating that objective just simply would have removed that alternative. And so they went with shortening the harvest season. So again, with a set of consequences, a fully completed consequence table, the decision still wasn't a no-brainer. It wasn't easy. They had to work through, and negotiate to figure out what was the alternative action that they were going to choose and that everyone could live with. And so the decision was made and implemented. So last slide, to summarize, SDM results in better decisions that are more likely to achieve objectives and be accepted by others. And the first level of structuring in SDM are the 5 main components, the ProACT. So remember that ProACT algorithm. Then this idea of objectives hierarchy and trying to wrap our heads around the values involved in our decision, which ones are the most important and how they relate to one another. And then this idea of a consequence table being a great summary of all the information relevant to a decision that can be a good communication tool. And I think, yeah, that's all I have, and we're probably very close to the end of time. So.
Yeah, well, that was great. Thanks a lot, Mike. Again, if you do have any questions, feel free to enter them into the chat area. I did also share the link for CEU credits and a webinar feedback form if you'd like to fill that out. We do have one question from Cloquet, and it's, how do you set weights for the objectives?
Good question. There are different ways to go about it, but what we often use, and what we used in this case, is a method referred to as swing weighting. So we look at, I'm going to scroll back to the consequence table. And these are unweighted, and again, we're not summarizing or over to the right, but we can ask ourselves, swing weighting, I'm trying to think the quickest, most concise way. Scale is important when we apply those weights. So you can think of a decision where, let's say the estimated sharp-tail abundance didn't vary much at all across. So it's if a performance on a particular objective doesn't vary very much across the alternatives, it might receive less weight than the same objective if the predicted consequences were more variable. So the scale of possible consequences matters. And so we incorporate that information in asking people that are involved and stakeholders, basically which objectives would you want to swing from the worst possible performance to the best possible performance on a given objective. And again, you end up with these relative weights that sum to 1, and then you can ask yourself, does looking at those two right-hand columns, DNR credibility and regulatory burden, is DNR credibility, does it seem like it should be about 3 times as important as the regulatory burden or the cost to the DNR? So each step provides information and context, but then we can check back and see if it's making sense, if it's feeling right, because all this is a summary of how a particular decision maker, how a particular stakeholder views the decision. There's no ultimate right, correct, and incorrect answer. It's just a representation of how we see things.
Great. Thank you, Mike. I'm not seeing any more questions coming online. And so I think we'll wrap up there. I do want to thank Mike for his time today and sharing his experiences with SDM. And so we are going to have a recording of this that we'll make available, and we'll email that out to anyone that's registered for this webinar. So you'll have that as well. And we'll also include, I shared a couple of links in the chat area. We'll also include those links too as a part of that email. Now that email probably won't arrive until later next week. That's just because some folks at SFEC are away. And so if you're waiting for the video or you're waiting for that approval for the CEU credits, that'll probably be late next week when you'll see that. And I did want to point you to next month's webinar. We're going to be talking about invasive plants in Minnesota's forests. And so I shared a link there in chat as well. So thank you again, Mike. It was great learning about this topic and diving in deep with it. And I hope you all have a good afternoon.
Yep, thanks.